Now let's go over trigonometry as it applies to points in a plane. Let P, xy, be a point in the plane that forms an angle theta with the positive x-axis. So our theta is this angle right here. And we're going to let the distance from P to O, the origin, be given by r, and it's also known as the terminal side. You could also think of it as r being the radius of the unit circle, or the circle that's created with the origin as its center. And we're going to let side PO, or segment PO, be the terminal side of this angle theta. For any point xy in the plane, the cosine of theta is defined as x, the initial side, or adjacent side, over the terminal side r, or the hypotenuse. And the sine is the opposite side, or y in this case, over the terminal side, or hypotenuse r, where x squared plus y squared is equal to the radius squared for r values greater than 0. And theta is the standard angle in degrees, whose initial side is the positive x-axis, and the terminal side includes x and y. For any point xy in the plane, cosine of theta is equal to x over r, and the sine of theta is equal to y over r, using the general sine and cosine ratios. If we were to solve each of these ratios or equations for x and y, we would end up multiplying both sides by our radius. So if we multiply both sides of the cosine theta equation by r, the two r's cancel out, and we get that x is equal to r times the cosine of theta. We can do the same for the sine ratio, or the sine equation. If sine is equal to y over r, if we multiply both sides by r, we end up getting that y by itself is equal to r times the sine of theta. And the slope of the terminal side joining P and O together is also known as the slope, which is going to be the rise, or y, over the run x, or r sine theta divided by r cosine theta, which ends up equaling the tangent of theta. Because again, opposite over adjacent is equal to tangent, so r sine theta divided by r cosine theta will give us that y over x, or the slope of our line. The sine, cosine, and tangent ratios were first introduced in geometry and then expanded upon in Algebra 2 to create the sine, cosine, and tangent functions. In pre-calculus, 3 more tangent ratios and functions are being added into this mix. We'll start off with their ratios. For any point xy in the coordinate plane, the cotangent function is given by x over y. You'll remember that the tangent of theta is equal to the opposite y over the adjacent x. So cotangent of theta is equal to 1 over tangent of theta, which is equal to 1 divided by y over x, which reduces to, when we rationalize the denominator, x over y. And this also allows us to multiply tangent and cotangent together, making their product equal 1. The secant function is given by r over x, and that's because the cosine of theta was equal to the adjacent side x divided by the hypotenuse r. So then secant of theta, which is equal to 1 over cosine of theta, is equal to 1 divided by x over r. And then if we multiply both if we multiply both the numerator and denominator by r over x, to rationalize, the denominator is perfectly fine, and 1 times r over x is equal to r over x. Therefore, secant of theta is equal to r over x. And the cosine of theta times secant of theta is equal to 1. Similarly, if we look at cosecant, it's given as r divided by y, and that is because the sine of theta is equal to the opposite y over the hypotenuse r. So cosecant of theta is equal to 1 divided by the sine of theta, which is equal to 1 divided by y over r. And again, if we rationalize and multiply by r over y to both the numerator and the denominator, we end up getting that cosecant of theta is equal to r divided by y. And we also know that sine of theta times the cosecant of theta is equal to 1. And each new function, as I explain here, is a reciprocal of our original sine, cosine, and tangent functions. So what we have found are the 6 trigonometric function values written as ratios. So the sine of theta is equal to the opposite y over the hypotenuse r. The cosine is equal to the adjacent x over the hypotenuse r. And the tangent is equal to the opposite y over the adjacent x. We found out that cotangent is the reciprocal of tangent, so that makes cotangent become the adjacent over the opposite, or x over y. It makes the secant be the hypotenuse over the adjacent, which is the reciprocal of cosine, and it makes cosecant be the radius over the opposite side, or the reciprocal of sine. Now let's try an example with the 6 trigonometric function ratio values. So let P be the point -4, 3, and it's a point in the plane that forms an angle theta with the positive x-axis. Let the distance from P to the origin be given by the radius. For this point, determine the 6 trigonometric function values. Well, we have theta here, and we also have a 3, 4, 5 triangle. That's how we came up with the radius value of 5. If you don't remember the special 3, 4, 5 triangle, you can always find that radius by using the Pythagorean Theorem. So 3 squared plus -4 squared is equal to our radius squared. We would have 9 and 16 would be equal to r squared, and that's 25 being r squared. And if we square root both sides, we get that the radius is indeed 5. So now let's use these values to determine the sine, cosine, tangent, cotangent, secant, and cosecant of our angle theta. So the sine of theta is equal to the opposite, or the y value of 3, divided by our terminal point, or the hypotenuse r. So that will end up being 3/5. Now let's look at cosine. Cosine is equal to the adjacent side, or the x value side, divided by the hypotenuse or terminal side. So because we're going in the negative direction along the x-axis, the cosine will be negative. It's going to be -4/5 instead of just regular 4/5. Again, that mainly has to do with the position of this point. Also notice that for cosine, we have the x-coordinate given to us as -4, and we found the length of the terminal side, or the radius value, or hypotenuse, to be 5. Similarly, with the sine value, it corresponded with the y-coordinate of our point over the hypotenuse, or length of the terminal side of our segment, or right triangle that is formed here. Now let's look at tangent. Tangent, you remember from geometry, is opposite over adjacent, which also makes it be y over x when you're talking about the coordinate plane. So that will be 3 over -4, or -3/4. Now let's look at our reciprocal ratios. Cotangent of theta is 1 over the tangent, or flip y and x around. It will become x over y, so that will be -4 divided by 3. And again, notice that these two are reciprocals of one another. Secant of theta corresponds with cosine, and it's the reciprocal of it. So instead of being the adjacent over the hypotenuse, it's going to be the hypotenuse over the adjacent, or the terminal side divided by the x, the length of this x value, including the sign because we're going in the negative direction here. So we're going to have -5/4 for that secant ratio. And then for cosecant, it is the reciprocal of sine. So it is going to be the terminal side of 5 divided by your opposite side, or the y value, which is 3. So we're going to have 5/3 as that value.